All right. Hello, everyone. My name is Vinny Cavello, and I'm one of the community admins here at the Maintenance Community by Upkeep. Thank you for joining us today for another fantastic webinar. We have George Williams joining us for a presentation on partnering with operations to identify and eliminate losses. Before we go ahead and start, I wanted to remind you that during the webinar, you can use the Q&A feature to submit your questions for our live Q&A at the end of the presentation. George will also be available to answer more questions in our Slack group following the conclusion of the webinar. Please also note that this session will be recorded and available on demand in the next day or so, along with a copy of the slides. If you're not already a member of the Maintenance Community Slack group, please go ahead and join us and also follow us on Instagram. I'll add those links in the chat in just a moment. And then one final note, if you can go ahead and expand your screen using the two separate arrows at the top of the camera, you can then see the full presentation provided by George. If you have any questions on how to do so, just again, go to the chat and I'll give you some more instructions. And on that note, I'm going to go ahead and pass it over to George.
Awesome. Thanks, Mr. Sloan. Good afternoon. Yeah, again, if you have any trouble expanding the camera, because we're not going to do voice over PowerPoint, not a big fan, so we're going to skip that part and get right into being at the whiteboard. So why don't we go do that now? All right, so welcome to partnering with operations to remove losses. My name's George Williams. I'm the founder and CEO of a young company called Reliability X. I have a master's degree in maintenance and reliability engineering from Monash University. I'm a CMRP, a CRL, a CMRP of the Year Award winner, blah, 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 25 years experience. Okay. Let's get into how do we partner with operations. So here's a couple of things we're going to talk about today. So we want to talk about what losses are in manufacturing. We want to cover what reliability is, and we want to cover which losses belong to maintenance. And we'll get into that in a pretty deep dive. We're also going to talk about what the perception of maintenance is in a manufacturing place, and how do those losses impact reliability. And how do we partner with operations? How do we create operational standards? And how do we eliminate defects? All of this being, how do we become more reliable as a manufacturing facility? So let's first define what losses are. So a loss is any disruption to normal operation with 100% quality and at design rate. Anything below that is considered a loss. If we are rejecting product, if we operate any slower, if the line stops for any reason, if we have no demand for the product and don't run the line, all of these things are losses to the potential value we would receive from the asset. If we think about the ISO 55000 definition of an asset, it's anything that adds real or potential value to the organization. And so there is potential value being lost if the line is not running. There's actual value being lost if the line is not running and we have demand. So we're going to go through all of that stuff. This is based on 24/7, 365. Now we know we have to do scheduled maintenance, but we're going to look at where that belongs in the loss buckets. So losses include both scheduled and unscheduled events. They include things like speeds being set below design rate, any rejects, your scheduled PMs, anything you have to do in terms of changeover time, or if there are problems at the line, even basic things like a product jam or a box jam. All of those are losses in manufacturing. So we're going to look at this in a much deeper dive. I know it's a bit of an eye chart. We're going to expand this so we can kind of see this a little bit better, but let's look at it in big, broad terms for now. All the way up top, we have what's called TEEP, or Total Effective Equipment Performance. TEEP is measured against calendar time. And so if we think about calendar time is everything. From calendar time, we remove all the lack of demand and all the scheduled downtime. That scheduled downtime leaves us at the potential maximum OEE. And so what we have now is this line here. All of this is unscheduled, and we're going to take a closer look at these in just a second. We then have everything OEE, so availability, performance, and quality losses. And we have what we achieved in OEE. So let's look deeper into what all these losses really are. So we talked about TEEP. The first bucket inside of this is loading losses. Loading losses are the scheduled downtime, the removal, what are we not doing to load up the machine? In some cases, we may have no demand. If we have no demand for our product, then we stop the line. And so the first loss is no demand. The next is operational downtime. So operations downtime includes changeovers. It includes time where we need to, say, clean the line, or operational PMs or CILs. All that is operations downtime. That's a loss. We could run good product, but we're not because we're taking care of the line, or we have some other reason operations takes it down. We then have scheduled engineering downtime. Scheduled engineering downtime may be things like running a test product or running a test to see if a configuration change has better performance. That's engineering downtime, scheduled engineering downtime. We then have scheduled maintenance time. And scheduled maintenance time, let's get a nice color for that. We have scheduled maintenance time. Scheduled maintenance time would be your preventive maintenance schedules. Anytime that you have the line down to perform a scheduled maintenance activity. So it could be corrective, it could be preventive in nature. This is our loading losses. This takes us from TEEP to a maximum capability of OEE. Inside OEE, our first bucket is this availability bucket. Our availability bucket, we're going to skip breakdowns for a second. Well, we'll go right to it. Why not? Why not just dive in? We'll go maintenance in red. Our first bucket are breakdowns. Breakdowns is anything that's 10 minutes or more but required a part to be replaced. And so if we show up at the line and something breaks and we replace the part, we have a breakdown. Sometimes maintenance shows up and they don't have to replace a part. There are plenty, like many times, we as maintenance show up at the line is down, we make some minor adjustments, but we didn't actually replace a part. If it is 10 minutes or more but does not require a part, that is a process failure. "10 minutes or more, no part replaced." The next bucket inside availability are setup and adjustment losses. And setup and adjustment losses are those adjustments which take place after the allotted changeover time. And so if changeover is expected to take 10 minutes, but the line is not producing good quality product until 20 minutes, we had a 10-minute setup and adjustment loss. So this takes care of our availability inside OEE. What's interesting is maintenance owns one little tiny sliver of this. And they own one little tiny sliver of loading losses. In total, at least in this section that we are working in right now, this is what maintenance owns. Inevitably, maintenance takes the blame or takes the hit for all of these. Anytime maintenance is called, they're getting hit with the availability bucket. In reality, there are plenty of times they are called that are process failures. Operations didn't know how to finish the setup properly, or operations had a jam and they couldn't unjam it. Issues that exist that are not maintenance-related issues because no part wore out or no part broke. And so maintenance is taking the hit on these giant availability bucket, even though they only own a tiny little piece. And we're going to talk about that throughout this webinar. So the next piece is the performance bucket. And inside the performance bucket, we have two major losses that pretty much comprise a vast majority of the losses in a plant. Our 80-20 rule, this is our 80 right here. Performance losses inside a manufacturing facility. They consist of minor stops, a minor stop being anything 10 minutes or less. It does not matter if a part was replaced or not. If a part can be replaced in less than 10 minutes, it should be an operator task. And so things like suction cups, vacuum generators getting clogged, these are minor stops in the scenario of performance losses. Box jams, product jams, all minor stop if they are cleared in less than 10 minutes. The next bucket are speed losses. Speed loss is anything below the design rate of the equipment. And so if you have designed your line to run 100 units a minute, but the speed setting of the line is 75, then you have a 25 unit per minute speed loss baked into your manufacturing. What tends to happen in manufacturing facilities is instead of saying all the time, we are losing 25 units a minute, they simply lower the expectation and measure themselves against 75. This masks opportunity. And so if you are in the maintenance organization, and as we go through this, become interested in where losses are, one of the things you should do is work with engineering to understand the design rate of your equipment. Not the target rate, not the budgeted rate, but the actual design rate of the equipment. Next to our performance losses sit our quality losses. And our quality losses sit in two major areas. One are in-process defects. In-process defects are things that get rejected by the line. Foreign material, overweights, underweights, those things are all in-process defects. And after in-process defects, we have startup defects. A startup defect is any material that is either recycled or reutilized or is purged as part of the ramp-up process for a line. So, for example, if you are a blow molding operation and you're blow molding soda bottles, you have to heat up the dies and get the Parison head going, and you have to extrude plastic long before you start actually blow molding bottles. And your initial blow molding requires you to make some minor adjustments to your blow pin tips and get everything set before a first good product ends up down the line. Those are startup defects. We're going to toss away that product or recycle that product and reuse it, but we have to do that as part of the changeover process. And so they are startup defects. Now, so in total, this is where all the losses exist. What was interesting is, we have to understand the difference between maintenance and reliability in a manufacturing setting. And so we saw what maintenance meant inside a manufacturing setting. And even in our industry today, when we speak about reliability, in large part, the effort is around the asset, and the effort is around the maintenance strategy of the asset. Even this community being called the maintenance community, there are many people here with the title of reliability engineer. And so are we focused on the asset and its breakdown potential, and how do we mitigate its breakdown versus the complete performance and value that the asset can derive? Well, let's look at what the definition of reliability is. And from ASQ's website, the definition of reliability that we're all familiar with, right, is mission success. Can we hit our mission time window with our intended function? And so this is our typical definition of reliability. Baked inside of that definition and direct from ASQ is that there are some important components to this definition. The first being probability, the likelihood of success. Will we survive this lot that we're trying to produce? Will we survive this batch? Will we survive till next week? Whatever the mission distance is. The next piece, which is specifically important for me, is the intended function piece. The intended function, in other words, to light, to cut, to rotate, or to heat, that's what's listed here. They're all asset functions. What I don't see here is really like a production line. The intended function of a production line is to produce high quality product at design rate. And so anything below that is unreliability. That means the box jam is unreliability. The asset didn't break. I'm not going to create a PM, but it's not reliable. Well, that turns what we typically think in terms of maintenance and reliability on its head, because the PM strategy is not fixing that. Because the PM strategy is not to inspect incoming corrugate. But we have a reliability problem of not inspecting incoming corrugate. And so we create jams in the tape machine or in the case erector. So how does maintenance deal with unreliability when they own reliability? You have a reliability department. Only part of that function is the maintenance strategy. And so we have to look at reliability. And how are we looking at reliability if all we're focused on is the maintenance strategy and how to plan and schedule and execute the maintenance technician? We're missing a huge opportunity, at least in the manufacturing space, to go after actual impactful unreliability. So what we want to talk about is how and why. If we go back to our losses graphic, what we realize here is that of all of the losses that exist, maintenance owns this. But this is reliability. Reliability is achieving the most value out of the asset we possibly can, which means maximizing even the scheduled downtime, right? Maintenance owns one of these buckets and so does operations. But when operations schedules downtime, maintenance should be scheduling their PMs as well so that that bucket becomes more narrow and we have more opportunity to run. So maintenance owns just these two little tiny buckets, planned and unplanned maintenance activities, breakdowns, and scheduled maintenance. Outside of that, there are lots and lots of losses in the manufacturing space. And this is reliability. Reliability is maximizing the value of the asset, which means it has to produce good quality product at design rate. And anything under that is a failure. Have we, as the maintenance organization, accepted that a minor stop and a speed loss is a failure and a failure mode that should be addressed? Because I've been through a lot of FMEAs, and unless it's a process FMEA, it hasn't addressed a box jam. And usually when you get to the process FMEA, it just says operator to clear the jam and restart the line. And that's really not addressing the issue. So what we want to look at is, can we address this as maintenance? As maintenance, how can we impact these areas that truly are not ours? So let's just use an example, because if you're in maintenance, and I'd love to see some stuff in the chat here about how maintenance gets kicked in the head when there's a 4-hour downtime event. How many people get called into an office or they're the topic of the next meeting because you happen to have a 4-hour downtime event? So in our example, we're going to look at a 4-hour downtime event that happens every week on a line running 50 units a minute. If we run 50 units a minute and we have a 4-hour downtime event once a week, we end up with 12,000 units lost each week, which equates to 624,000 units a year at 5 days a week and 52 weeks a year. 624,000 units. That's a big maintenance problem. It's huge, right? And you're getting called into the production office and getting screamed at because, well, you caused 4 hours of downtime. I mean, maintenance is not doing a very good job here, right? And again, throw some comments in the chat. I'd love to hear your feedback on how often these types of things happen. So the next day, when you're having your morning meeting, the operations manager, plant manager, whatever that title is saying, hey, we had a 4-hour downtime event on this line. What's going on? You're killing me. I can't make my numbers. And as maintenance, you're going, here I'm getting killed again. 4-hour downtime event. And you should be. You shouldn't have the 4-hour downtime event. Here's what's interesting. Let's take a really common scenario. In a common scenario, we've got a 5-minute downtime event that happens every hour for boxes jamming inside our case erector. The same line running 50 units a minute with only 5 minutes of downtime once an hour ends up at 26,000 units a week, or 1.3 million units a year, but no one ever sees this event because it happens all day long and doesn't last 2 hours. But it happens over and over and over. And not just on this line, but on many lines. And not only this problem happens, but printer ribbon breaks on a regular basis. Or, we put in the wrong lot number and did half a pallet before we realized it. And all of these other things are happening that have nothing to do with the maintenance organization, but because they didn't last 4 hours in one event, it meant we didn't see it. We're not understanding it. It didn't jump up on the radar. And so as a maintenance organization, we're getting kicked in the head for the 4-hour downtime event, which we should. We have to go remedy that. We have to fix that. We have to reduce the probability of reoccurrence. But all day long, we're having minor stop issues and process failures that have nothing to do with maintenance that total a dramatically larger number than the maintenance downtime. And so what we as maintenance have to learn is A, clean your own house, don't have the 4-hour downtime event, right? Follow all the practices you should be following on the maintenance side. But 2 is to learn this. It takes a lot more than a good car to win races. You can have the perfect car, you can have a great maintenance strategy, but you have to have operational standards. You have to have a race plan. You have to have well-trained operators. You have to have a good driver, or you're not going to win a lot of races. And in a lot of manufacturing environments today, the operators are undertrained. There's a lack of standards. They don't spend time cleaning the equipment and doing CILs. And so because of that, we have a lot of breakdowns, or we have a lot of process failures. And so we're not seeing good race quality. We're losing races. We're not getting to the potential capacity we have in the plant. Instead, we'll add another line. And I see this all the time. One of the interesting pieces of what I see all the time is a plant that changes their targets, right? So we design the unit. Let's say we design the unit. Let's say we design the unit, the line to run 100 units a minute. So 85% OEE should be giving us 85 units a minute. But what we actually see out of the unit is about 40 or 50. Let's say we're running at 50 units a minute in actual, what we actually get out of the line. They'll put in another line and they'll still only design it as though they're going to hit 85% OEE. And in reality, they're hitting 50% OEE. And so engineering comes in and they say, okay, well, we need another 100 units a minute to satisfy our next 5 years expected customer base. So they design a unit at 100. Sorry, we need 85 units a minute, expecting 85, even though the entire plant history says we can't do better than 50. And so they're setting themselves up for failure because the whole plant culture is not one of having operational standards and not having all of this. And so what happens is they've designed it below your capability as a culture because you've not set it up for success. And so they just keep adding more equipment and adding more equipment. Let me give you a hint. It's not the machine that's the problem. And so if you're maintenance today and you're being blamed for everything that sits in those buckets, operations is setting you up for failure. Because in the morning meeting, you're answering to why we didn't hit numbers and you have a fractional impact to that. We want to arm you with the capability of understanding losses so that you can actually turn the table on that conversation. And turning the table on that conversation kind of goes like this. Yep, you're right. I own that 4-hour downtime event. But yesterday we had, these minor stops, and in total, that cost us 5 times that across all of our lines. So where are those losses and who's accountable to those? And it's not because you want to point the finger in another direction. What I want you to do is help operations solution those problems. How do you as maintenance help operations solution those problems? So the aha moment is really when maintenance responds and fixes issues that are not maintenance related issues. So if you're not sure if this is an issue in your plant, there's 2 things you have to do. Number 1, change the color of your pen. You have to account for everything as a work order. If maintenance responds to the line because they got tapped on the shoulder and they make a small adjustment, it's unacceptable not to have a work order. And I'm going to tell you why. You have to have this data because in order to see the aha moment, you have to be able to look in your CMMS system or in your SCADA information if you have it and understand where maintenance is responding but not spending money on parts. So in your CMMS, I want you to look up all of the work orders, right, that are all of the work orders that exist that are emergencies, plus no material costs. Look up all of the work that exists that where maintenance had an emergency work order, but there are 0 material costs. That means you went to the line and no part broke. And you had to stop what you were doing to go do it. That means the line was down, but nothing was actually wrong. Or what was wrong was a process failure because they didn't know how to run the machine, or you had bad corrugate or bad raw materials because you don't have an incoming inspection, blah, 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 right? Procurement needed to save a penny, so they bought cheaper stuff. Cheaper stuff doesn't run on the line well, and so maintenance responds. These are issues that you're dealing with every day as maintenance. When maintenance responds and they fix the issue but didn't have to replace a part, this is a gigantic red flag that operations doesn't know the sequencing of their own machine. They don't know the center lining settings for their own machine, or they have not inspected incoming raw materials. If maintenance responds and gets the line to run without replacing any parts, that means operations failed itself. And that's an area that maintenance, because they actually get the line running, that means you have the expertise to create the standards and train operations to not have those losses. So a couple of areas that you should focus on for opportunity to help partner with operations. Emergency breakdown work orders with zero material costs. We just talked about that. That means maintenance is responding, but no part was replaced. That means process failure, bad incoming raw material, et cetera, et cetera. Calculate the hours that are spent on these work orders, and then work with engineering to understand the design rate of that piece of equipment. So for example, let's say, again, we'll use that 50 units a minute. We've got a line that runs 50 units a minute. And our total sum was, I don't know, 50 hours that we spent doing work where we didn't replace a part in, say, the last year. So we have to do 50 units a minute. Let's just do it this way. 50 units a minute times 50 hours times 60. Right? Is that right? No, we got to add more zeros than that. 1, 2, 3. 1, 2, 3. Oh, that's a big number. That's 150,000 units that didn't get manufactured. Where are the units? Operations is perfectly fine not producing the units. So we decide not to produce the units every day. But because it's a 1-minute stop or a 2-minute stop or a 3-minute stop, it never gets noticed. So as maintenance, start to quantify what those losses mean to the business. Work with finance to figure out what that cost to produce is. So if it's 150,000 units that we lost and they're $1 a piece, there's $150,000 sitting on the table in lost product. Another area of opportunity is to use your SCADA system. So your SCADA system, your supervisory control and data acquisition system, can use OEE as a calculation because it knows all the machine start and stop times. Now, in some cases, people you get, as the end user, you get to configure that in the system, and maybe you're not calculating OEE as it should be calculated. So you'll have to do a little homework there. If that's not available, you can stand at the line with a stopwatch. And we have done this. Stand at the line, you start doing time studies. What type of jams happen all day long, or what type of problems, and how long do they last on average? And you do that for a few days at a specific line. You get a rough idea of what type of losses exist at the line. And again, you can do the math and get down to actual dollars lost. The easiest way to do this is just talk to the experts, talk to operators, talk to maintenance technicians, find out what their headaches are. If you're walking through the plant and you see operators running around like chickens with their heads cut off, trying to load this and unjam that, and it looks like chaos, then that's a pretty good indicator that there's a significant amount of losses within the plant. And then you'll have to kind of Pareto that, talk to them about what their biggest issues are, and start to quantify those issues. Anything that's a nightmare. Things like lots on hold, material wastes, anything that gives them a nightmare as an operator. Ask maintenance which areas they respond to most often but don't have to replace parts, just in case you don't have that data inside the CMMS. Even without the data, you can find areas to improve the plant. So some variables inside the math, you have to know your run rate, and that may be in units per minute or units per day if it's a big, large assembly manufacturing facility. How many hours per day does the line run? Maybe you run 21 hours because there's breaks and lunches and the lines don't run, or maybe it's 24 hours, or maybe you run 2 shifts and it's 16 hours. You need to know how often the line runs per day, and then you need to know how many days per week that line runs. And then you need to know what the cost per unit is, and so you have to get that from finance. In some cases, they may average this, which, not a great fan of, but get down to some number that finance agrees you can use in your cost justifications. Okay, so here we have an example. Nope, don't do that. Let's run that. So here we're going to watch an example of a line running. And this is the before side, and this is the after side. And what I want you to notice is the control of the bag. See if you see a difference in speed. I don't know. See if you see a difference in control of the operation and the complexities that this creates. And it's only a 30-second video, so let's take a quick look. Okay, so in this example, this is actually from one of our clients. What you noticed on the right-hand side, where some of these bags are falling forward, some of them are falling backwards, some of them are upside down, and so the packaging person at the end of the line now has to turn them the other way to get them into a box, not just pick them up. And if you had a robot there, now they're backwards because the robot sure is not flipping them over. And so there's a lot of issues here, and it creates double bags over the check weigher. It creates issues going through farm material reject because of it being piled up. There's lots of issues going on here. On this side, we have good, clean control of the bag. And what that allows us to do is, as we move through the line, create separation and create a much better mechanism for going over check weigh and through visual inspection or farm material inspection. And so we have a much cleaner operation. Walking by those lines, you don't see a speed difference happening. But in that short video, 30-second video, there was a 6-unit difference. If you happen to be able to count them coming off the screen, in a 30-second video, you have 6 more units on one side. That little tiny, tiny speed difference is 12 units a minute, 720 units an hour, 5,000 units per shift, at 15,000 units a day, and 3.8 million units in a year for a minor speed loss. And remember, the speed losses typically are to mask other problems. And so if you solve the other problems, you can speed the line up back to closer or at its design rate. That's huge. That's huge. We adjusted the angle of a plate, put in a small intermediary conveyor to create separation, and it's 3.8 million units. And this line's actually faster now. This was just an example we had early on this project. That's a huge difference, huge. So how do we, once we've identified some opportunity, we have to put in some process to get this done. And so we work with operations to understand the opportunity, but what we're trying to do is get permission to do some stuff. And what is the stuff we got to do? Because a new PM's not solving it. We have an unreliability issue that's not a maintenance issue. but maintenance has the expertise to solve it. What they don't do is partner well with operations on the overall goal of reliability. And so what we want to do is walk and go through some process steps, and we're going to give you what those are. The first thing we do is clean the entire machine. Top to bottom, clean the machine. And you clean it with leadership. You make leadership get out there and clean it. And we'll walk through why. Then put it in auditing standard so that you are auditing that cleaning. Each shift, at the end of the shift, should be cleaning their machine and presenting the line to the next shift. And that shift should be deciding if the line was cleaned appropriately or not. And so you get some accountability into the system. If it is clean, it's easy to inspect. We then restored everything to base condition and center line the equipment. That means getting it back to where it was at SAT and FAT and getting it where it needs to be to appropriately run. We developed things like CILs and operational standards for changeovers and how to operate the line. And then, of course, we train on those standards. But far beyond that, train your operators in what losses are. Train your operators that losses are unacceptable, that they should be complaining to their supervisor if they have box jams. Instead, we deal with these issues over and over and over again. That should be unacceptable to anyone in the plant, including the operator. So stand next to those folks and coach them as to why certain adjustments can or can't be made, and why certain adjustments are rigid and certain ones have some span of control. They don't necessarily understand the sequence of operation of the line. And in some cases, maybe English isn't their first language, but that doesn't make them inept. They're smart people that run the lines. We have to coach them and train them and get them to a point of being able to operate and run the line effectively. We then created a defect elimination process. And we're going to go over this in just a little bit more detail. I know we're going to be running out of time, so we're going to go through this. But our defect elimination process for us just means registering a defect and then project managing it until it's gone. And so the last step here is to verify results. And if a defect is more complicated than that, go through the root cause analysis process where necessary. This is an example of a cleaning standard. So we see a cleaning standard, we see some center lining markings. We cleaned this particular machine, and the person who was in the plant when the plant was first built was noticing corrugate that they don't use anymore. And saying, you know, these pieces of corrugate are from like 10 years ago because we don't even run these boxes anymore. So clean the machine, give it center lining markings so that they can easily do their changeovers, and you hold them accountable to that. In the elimination of defects process, we work with operations to identify problems and then create projects that help eliminate those. So we'll just give you a brief example of that really fast. Let's first do this. So in this case, we've got a defect elimination page, and in that defect elimination page, we can view these things by priority. So in this case, our biggest priority defect is this speed loss. And if I click on that speed loss, I can get more details of that speed loss, but also below that, I can get the task list associated with solving the speed loss and what we needed to do to solve the speed loss. And if I click on any of those, I can go to the details there. I can see who it was assigned to, when it had to get done. I can even come as far down as seeing what work order number is associated to it. And each of these losses get put into buckets. So when I look at the speed loss, for example, here, I can look at specific categories of that loss. If I go to edit, I can come down here and I can choose what type of loss it is based on the categories we talked to you earlier about. And then based on selecting one of those, I can select if it's a speed loss, scheduled downtime. All these are sitting inside of OEE. So I can select any one of these that is appropriate. And that kind of buckets my defects so that I can look at least at my home page. Hopefully this actually produces fast enough. Sometimes that takes a little while. It's got to go to the server and do some math. Come on, baby, you can do it. No, don't do that. All right, well, it'll show up behind me in a second. So we can go there and get charts that kind of say, okay, here's how many speed losses we have versus minor stops. And that kind of tells us what types of issues we have to deal with and how best the solution knows if they are process failures mainly versus speed losses versus minor stops, we would address those slightly differently. So apparently they're going to take longer. I'm not worried about that. Let's just get back to our deck. Hey, look, the chart showed up. Oh, not there. Why gotta do that? Sorry for the technical glitch. Give me just a second. Of course not. Not what I'm looking for. Why gotta give me a technical glitch? Yay. Okay. All right. So document and those issues and the impact to the business that exists. Prioritize your defect. Create a collaborative solution. So work with operations and finance and HR and whoever you have to help understand the defect. What inevitably happens is, your company has this reduced cost to produce goal. And so because they have this reduced cost to produce goal, someone in procurement says, hey, I can save a penny per box if I allow them to cut it in a higher stack. Cutting it in a higher stack means I'll have more variation in my boxes. And so they're saying, hey, I saved a penny a box over millions of boxes. I'm a hero. I saved us, 10 grand last year and Cargan. Meanwhile, out at the plant, the box is jamming every 2 minutes because it's got too much variation in it, but no one sees it again. And we think procurement did a great job and the plant manager is getting kicked in the head because performance is down. But no one is relating those things because the operation doesn't understand reliability holistically. So collaborate and create solutions, train all those folks on what reliability is. This can be done at the line. The best scenario here is you just solve the problems at the line. If they are more complicated, register them in a formalized defect elimination process. Escalate if there's a root cause analysis that's needed, implement your solutions, and then go back and measure your performance. So in this particular example, we have a line that we worked on look at, this is crazy. So let me just go through the numbers on this particular line. This particular line produced 3.8 million units in 2019. This was a year old, this data. In 2019, 3.8 million units. In order to do that, they ran 3 shifts a day, 5 days a week, plus 77 weekend shifts. In 2020, this line did 4.9 million units. It ran first shift 5 days a week and second shift twice a week. And that's it. No weekends. We more than doubled this line's output by partnering with operations and focusing on reliability, not maintenance. To do this, we spent $1,100 on this machine. It's not the equipment that's the problem. It's not maintenance that's usually the problem. It's usually standards and education to understand the sequence of operation and centerlining the equipment and good incoming raw inspections. There are many factors to why the line is unreliable. In most cases, the factors are not the equipment or maintenance. And so what we're suggesting is partner with operations, develop good standards, and eliminate defects, because your goal is reliability of the process. It's not just maintenance. So what we want to do is bridge that gap between maintenance and operations, and that'll help you become more reliable as an organization. All right, so that's all I have. Why don't we go through and see if there are questions?
All right, thank you for that, George. We actually have a handful of questions. I'll start off by saying William Sloan said these events happen every day. We have to report any downtime greater than 10 minutes. We roll a car off the line every 72 seconds. It all adds up quick.
Yeah, no doubt. Any downtime. So you report downtime that's greater than 10 minutes, but think about how much downtime exists that is far below that 10-minute mark. And if it is repetitive each day, greater than 10 minutes, you're missing a significant opportunity, right? Especially with a car every 72 seconds.
Oh. So we have Moretti, who said, what is the right measure for key performance indicator for maintenance in percentage terms?
What is the right measure for maintenance? So in a manufacturing setting, maintenance only owns breakdowns. And so what we want to know is a measure of a percentage of overall OEE that maintenance owns. In terms of the maintainability of equipment, there's a lot of different metrics in that space. Percentage of maintenance costs against replacement asset value is a typical standard. I would say, though, because this presentation focused on performance in a manufacturing setting, I would look at maintenance's impact to OEE, which is the breakdown bucket, and the scheduled downtime bucket is part of TEEP. But I would look at the percentage of OEE impact by maintenance, but it has to be bucketed right. The only thing they own is 10 minutes or more and required a part.
Fantastic. So Marty actually had a follow-up question. In changing standards, is there a change control procedure that ensures safety and design changes from maintenance are recorded on drawing for revisions?
Yeah. So the short answer to that is, yeah, absolutely, it should be. The long answer to that is typically that depends on your industry. So if you're in pharmaceuticals or medical devices, absolutely. But many times in food, people just make changes and they're not really documented. Matter of fact, you'd be thrilled to death if a standard exists, let alone if they're doing change management, change control on that standard. So management of change is certainly something that should exist for your formalized standards and documentation in any setting. As long as it's not, it should not inhibit your ability to make progress, though, right? Like it can't be cumbersome to do.
Great, thank you. Raul says, is there any priority list of KPIs that which should be monitored mandatorily and which can be left or delayed?
That's going to depend on your organizational objectives. And I know that's a terrible answer because you wanted a list of KPIs. However, if your organization's objectives are to reduce cost, you shouldn't be measuring, number of PMs executed. Like it has nothing to do with your company's objectives. Your KPIs, or key performance indicators, have to be the way that you are measuring the progress of the maintenance organization and achieving the overall organizational goals. So if there's not a line of sight between your KPI and the company goals, then that would be the place I would focus on first. I know that's probably not what you were looking for, but if I blurt out a list of KPIs and they're not aligned to your company organizational goals, then I did you an injustice.
All right, and I'll go ahead and give Raul a moment to see if he has any additional comments since he is on with us. And then just a reminder to our audience, you can go ahead and submit your questions through the chat feature.
I hope this was valuable.
It was fantastic and engaging having the presentation behind you. It was very well done and appreciated. Looks like, and William said very valuable. All right. It looks like that is all the questions we have today. Unless you have any, last minute comments, I would like to direct everyone over to the Slack group, because there we can continue the conversation. I'll put a message in there to connect everyone with George after this.
I just want to thank everyone for coming and being an active participant. I appreciate that very much.
All right. Thank you, everyone. And the on-demand version will be available soon. All right. And William says, thanks for presenting. You're getting a handful of thank yous there. All right. Appreciate it. Have a good rest of your day, everyone.
Bye now.